Alright, so just draw another triangle, ABC. Little a is 9, little b, 7, little c, 5. Which angle are you going to find first? I would find angle A. What will happen is, how many obtuse angles can you have in a triangle? One, right? So if there's going to be one, the law of cosines would find it first. Once I have found that first angle, then you really have choice between law of sines, law of cosines. Right? So we're going to find angle A first. It's the largest angle. So again, finding angles. I just go right into law of cosines because I just want to punch it all in the calculator. Now, if you're the type of person you don't want to memorize 2 different formulas for the law of cosines, write it the way I've shown you, and then just subtract every time you do it. But 5 and 7 are the 2 sides that we're going to use twice. So we can go 5 squared plus 7 squared, and then remember the partner side, I'll do, like that, 9 squared. It gets subtracted at the end up top, and then 2 times 5 times 7. So we did go through that extra step of making sure that we got rid of some of the negative signs. And some of you are going to have troubles typing that in. And so one of the things that I suggest you do is do the top of the the numerator of the cosine stuff, do the bottom, divide them, and then hit a second cosine, second negative. Punch your answer in. So what I mean by that is you could go, what was it up top? 5 squared plus 7 squared minus 9 squared. So that's the answer that you have up top. And then on the bottom you had 2 times 9. No. Got it? 5 and 7 are down below. 5 times 7, thank you. So that's the number on the bottom. So you can go top number divided by the bottom number. And then you go second cosine, second negative. Right? Otherwise, do what I did before. You hit inverse cosine, you get a parentheses, put another one in for the top, close it, divide, open it. You're doing a lot of extra parentheses, whatever. 95.74. 95.74 degrees. So it is slightly obtuse, a little more than 90. I want you to finish the problem now with somebody sitting near you. I would just go ahead and let's all find angle B first, and then we'll do 180 minus the sum to find angle C. For angle B, because you have pulled out the obtuse angle, you can use law of sines or cosines now. You have a choice. You can do either one you want. So with somebody working near you, find the last 2 angles. So again, I did law of cosines, and I got 50.7. Did anybody do the law of sines? Get the same answer? And then the last one, angle C, 180 minus the sum, you'll get 33.6. So again, as you're doing these problems, you're going to be working with a ton of decimals. So do what you can to carry at least round correctly to the first decimal or 2. I would, even going out to the 100th a couple times doesn't hurt. Are we good on that one?
Oh, yeah. Yep.
Okay. The bad thing about a problem like this is that if you don't understand baseball or don't know anything about baseball, you would have a hard time doing the problem. At least I'll set it up for you and show you what's happening. Okay, on a baseball diamond with 90-foot bases, so you're talking 90 feet between bases. The pitcher's mound is 60.5 feet, so 60 feet 6 inches is what the pitcher to home plate is, so 60.5 feet. So $60.5. How far is it from the pitcher's mound to third base? So they are looking. I don't know if the white will show up. Will the white show up? That'll be good. Won't it? So our X can sit there. Now, the assumption that people make for a baseball diamond is that the pitcher's mound is in the center of the field, and it's not. It's slightly in front. Pitcher is actually slightly in front of center. So that's your diagram. That's the given information. We're looking for side X. So what do we have to know? You know, it actually goes back to a little bit of geometry. What do we have to know about this problem?
This is just a side question. Can we assume that angle by home plate is 45 even?
It is not an assumption. It is.
It is for a fact.
It is a fact. Yes. So basically, a baseball diamond, right, is a square. So all bases are 90 degrees. So it is true that the pitcher's mound sits on that line, the diagonal, which means we bisect down here. Can't see that? So it does bisect that angle, and so now you have side angle side set up. So to find X, I can do the square root of 90 squared plus 60.5 squared minus 2 times 90 times 60.5 cosine of 45. So quickly give me that number. What are we getting? $63 what?
I don't know. I didn't do it.
63.7 feet. So here's what I did over on this side is that's where your 63.72 feet comes into play. And then in this diagram, what we do is we look at, okay, 90 plus 90, if you look at finding the diagonal, so from like home to second, it's actually 127 feet. So if you split that up, you know, you're looking at what, 63.5 feet to here, and then you're still another 2 feet in front, so they're quite a bit in front of center.